Okay, a lot of people are struggling with question number 3 on the assignment, so I'm going to do a similar question. I won't do that question with you, but a similar one that I just made up here. Okay, it's got two vectors that are complex, that are weird, and if we can add these two, we can add anything, really. And so let's figure out how to do this. So a lot of times what you feel like doing to start is you feel like doing 12 meters this way, and then 11 meters down this way. Well, let's make this quite a bit longer. And then what we want to find then would be the resultant here. This can seem a bit tricky because if we do this, which angle do we take? Do we take this angle? Is that? But no, that's not right because we actually want to determine it based on like east or north. So we could find this angle. That would work. But boy, that's tricky. How do we do this with 12 and 11 that are at such weird angles? If this is 31 and what's even 22? It would be this angle would be 22, right? It's tough. This is tough. And so what we want to do is let's not think about this right away. It's too complicated. We'll get there and we will find this R. We will find it. But let's find a better way to find it, okay? Because another way to determine this 12 meters would be to say 12 meters, 31 degrees. Well, what is this 31 degrees, by the way? It is starting from east, we're going towards the north. So this would be 31 degrees. I don't need to do that. Whoops. Let's just do, there we go. 31 degrees north of east, by the way. And this 22 degrees would be, we started off going south and we went towards the east. So this would be east of the south that we started going. Just so you know. Another way of saying 12 meters here, 31 degrees north of east, is to say we went so far east and then we went a distance towards the north. Now this I'm going to call x1 and this I'm going to find y1. And this is going to be much easier to work with x and y rather than working with 12 meters 31 degrees north of east. Because x, this is going to be east, right? This is going to be east. This is going to be north. And that's much easier to work with. And so here, we're going to work with some value, and I'll call this y2 instead of y1, because we need to distinguish between the two y values, and this x2. And together, we'll find the total distance we went east by adding these two components, x1 and x2, and the total distance we went north or south by subtracting y2 from y1, right? And we'll find out if we went more north or south, and then we'll get an easy triangle to solve for r. So that's our strategy. So let's get going. Where we're going to start is we're going to start off by solving for x1. And the way we're going to do that is we're going to use SOHCAHTOA. Okay? And SOHCAHTOA, with this angle here, this 31, we've got x is the adjacent, y is the opposite, 12 is hypotenuse. So we want to use the hypotenuse to get the adjacent, so we're going to do cosine. And so cos of 31 is the adjacent, x1, over the hypotenuse, which is 12, which means x1 is going to be 12 times cos 31. And that gives us a value of 10. 10.3. Proper sig figs would give us 2 sig figs, right? Meters. All right, we also need to find y1. And so to find y1, we are going to, well, now we're doing opposite and hypotenuse, so we're going to do sine 31. And we're going to see that this is very similar to our first step of y1 over 12, opposite over hypotenuse. And so y1 equals 12 times sine 31. Man, this looks just like this line, hey? It looks very much the same. And so what we're going to do is 12 times sine 31 is 6.2. Meters. All right, so we did that. We've got our y, and let's just specify this would be east, and this would be north. Okay, now just draw a line. I'm going to do, might as well do the x's together, x2. To find x2, this time, let's be careful. We're using this angle, so this is the adjacent and this is the hypotenuse. Okay, this is the opposite, and this is the hypotenuse. And so to find x, now we're going to use sine. And so on this triangle, so now I'm looking for this triangle here, we've got x2 is sine 22 of the opposite, which is x2 over the hypotenuse, which is 11, which means x2 equals 11 times sine 22. Okay, hopefully you're seeing some repetition. And we have 4.1 meters, and this would be east. And then we've got to do y2. Y2 would be, now we're using the adjacent, so we got cos of 22 is y2 over 11, and so y2 equals 11 times cos 22, and we get our answer of 11 cos 22 gives us 10.2, which would be 10 with 2 sig figs. Oh, brutal. I gave you a bad question. No, that's good. Sorry, I got it mixed up. 10 with 2 sig figs, and it's going to be, this is down, so that is south. All right, here we go. Now, are we done? No, but we did some good work. We are done with these. We can now basically scratch them out and say, I don't care about these anymore. I just care about these 4 values. All right, and so if we draw this out, then we'll get our resultant vector. And so we went, let's do the x's. X direction, okay? The x's, we went 10 east, and then we went 4 east. So we've got a total of 10 meters plus 4 meters, and we got 4.1 meters, and we get a total adding would be 14 meters. Right? East. Let's do our y direction. Y direction would be, we went 6.2 north, and then we went 10 south. So we got 6.2 north, meters north, and then 10 meters south. And we get a total of, maybe I should do this in a different color. There we go. Okay, we got here 14 meters. And here we've got a total of 3.8 meters south. I know you can argue with me, this is subtraction, so we should just keep 4 meters south. Forget it, okay? I'm keeping 2 sig figs. If you don't like it, neither do I. This is not good. All right, so now we've simplified all of this up here, we've simplified into 2 vectors, 14 meters east and 3.8 meters south. Okay, which means that is ultimately where we went, which means this triangle here was really, this was 14 meters and down was 3.8 meters. So our drawing was helpful to see what was actually happening, but these red numbers, this is much better than this 12 and this 11, which were garbage, right? And now we've got better numbers. And so what we did is we broke them down into what we call, these are components, okay? The x1, y1, x2, y2. We broke them down to components. We added those components and we get 2 vectors to describe the in total motion. And now we make a final triangle. The final triangle. And we get this. We get 14 east and 3.8 meters south. And then once we've got that, then we do our final answer stuff. To do that, do this here. Pink, we're looking for this. This is R, and we're looking for this theta. And this is how we do it. Tip to tail, remember 14 meters east, and then 3.8 meters south, which means this angle is going to be south of east, right? And so let's figure it out. The angle that we find, we use tan. So tan of the angle is the opposite over the adjacent, because that's what we know. This is the right angle, and we're thinking about this angle, And so this is the opposite of that angle here. This is opposite of this angle, and this is the adjacent to this angle. And so tan theta is 3.8 over 14, and that means theta is second function tan, or inverse tan, of those numbers, 3.8 over 14. So this is what I punch in my calculator, and I get an angle of second tan bracket 3.8 over 14. Just to be careful, I use brackets all the time. I get theta equals 15 degrees. Wow, pretty sharp. Well, let's not sharp. All right, and then we have to find r. So this is a squared plus b squared equals c squared. So r squared equals 3.8 squared plus 14 squared, which means r is the square root of 3.8 squared plus 14 squared. This is what I punch in my calculator, and r is 14.5, so that's 15 meters. What direction? Let's put it all together. Our final answer is 15 meters. R equals with an angle of 15 degrees south of east, what we said, right? And so that's how you put it all together. So that's a big question, right? We started off with two complex vectors here. Drawing them was tough, so we broke it into components. And then we found the resultant x and y components, and then we made our final triangle down here, where we found the angle, and then found the length, and the magnitude plus the direction gives us our final vector. That's it.